Hello, sixth grade. This is Investigation 1.2 summary. Anything I write down, please write down also. And if you need to pause at any point, go for it. So 1.2, in this one, we did fundraising thermometers, and our focus was an introduction to ratios. So our definition of a ratio is a comparison of two quantities written as a common fraction or with the word to or with a colon. So we're going to write the ratios of hearts to moons. And it's very important, the order. It said hearts to moons. So I have 1, 2, 3 hearts and 2 moons. So as a fraction, we're just going to go 3 to 2. And we're going to leave it that way. I know a lot of you think fractions automatically need to be put into a mixed number, but that wouldn't make sense because we're dealing with a ratio. So it has to be 3 to 2. In its to format, very simple, we're just going to write 3, the word 2, and then the number 2, and then colon is 3 colon 2. All three of these are read as 3 to 2. This is not read as 3 halves. It's 3 to 2, 3 to 2, 3 to 2. Okay? Now, when we're dealing with ratios, we're comparing something. So we have two ways of writing a comparison statement. The first one is called the for every statement. And an example, for every 3 hearts, there are 2 moons. Then there is a ratio statement. And this would be, you're starting off with saying the ratio of hearts to moons is 3 to 2. And again, we know that 3 represents our hearts because it comes first, and our moons come second, and that is why our 2 is second. Ratios can be equivalent to each other, just like fractions can be equivalent to each other. So if the same relationship is showing using different numbers, then the ratios are equivalent. 60 to 90 is the same as saying 30 to 45. When both numbers in the first ratio are divided by 2, it equals the second ratio. I could show you that if we put it into fraction format. 60 to 90, does it equal 30 to 45? Well, if I divide that by 2, 60 divided by 2 is 30, and 90 divided by 2 is 45. So these two ratios are equivalent. 12 to 15 is the same as 36 to 45. When both numbers in the first ratio are multiplied by 3, it equals the second ratio. So again, I can prove it fraction form. 12 to 15, does it equal 36 to 45? So if I multiply that by 3, I get 36. If I multiply 15 by 3, I get 45. So this statement is true, and these two ratios are equivalent. Let's move on to the next page and try some of this. So pause it here, and you're going to do for the example, for every $360 that the 7th grade raise, the 8th grade raises $120. Pause it here and write the 3 formats. Okay, so my fraction would be 360 to 120 if I am doing 7th to 8th. If I was doing 8th to 7th, I would flip it over and it would be 120 to 360. My 2 format, 360 to 120, and my colon, 360 colon 120. Write as a ratio statement. So again, my ratio statement says the ratio of 7th grade to 8th grade is 360 to 120. Okay, could I simplify that? Yes, and that's what here it wants to write 2 other ratios that are equivalent to the previous statement. Pause here and give me 2 ratios that are equivalent. Okay, so we can have an infinite number of equivalent ratios. My first thing is they end in 0, so I'm going to divide by 2, and I will get 360 to 12. I also can multiply them if I want to. Okay, if I want to make it 360 to 120 and multiply it by 2, I would get 720 to 240. Okay, and there's many different ones. You might have had different equivalent ratios. but as long as your top number and your bottom number are divided or multiplied by the same number, your answer will be good. So that is the summary notes for 1.2 in comparing bits and pieces.